At the peak of the last ice age, the air was so cold and dry that it barely snowed. Sea level was 300 feet lower than today because the water was trapped in the thick sheets of ice that covered the northern hemisphere. How much colder was it back then? Scientists at the University of Arizona found that the global average temperature was between 4 and 7 degrees Celsius cooler at that time. Put in those terms, each degree of change represents major repercussions. Since the 1970s, water in the Gulf of Mexico has increased about 1 degree Celsius.
I work on climate modeling and using climate models to predict the future of the climate system. And we see in our models that the ocean temperatures are rising. And so hurricanes are likely to be more intense.
With each degree Celsius of rising sea temperature, the wind intensity can rise by 20 miles per hour.
So we can run experiments with our models where we look at a particular hurricane that might have occurred in reality and let the model simulate that hurricane and do it with the present day sea surface temperatures. And then we can run a counterfactual case where you cool those sea surface temperatures, say take them back to the temperatures that they might have been 40 years ago, and look at how does that change the behavior of this individual hurricane.
That's one way climatologists are helping institutions like the IMF and insurance agencies calculate the financial costs of each degree of warming.
So there are quite a lot of climate scientists that have ended up going and working in the reinsurance industry because there's a real need for them to be predicting how our extreme events like hurricanes going to change.
An increase in wind speed isn't the only factor that comes along with increasing temperatures.
There's one pretty clear signal in the models when it comes to hurricanes and extreme precipitation is that we end up with more moisture in the atmosphere because a warmer atmosphere can hold more moisture.
With each degree Celsius of warming, the air can hold 7% more water vapor. This means record rainfall, resulting in floods, mudslides, and erosion. It also increases the air's ability to dry out the land.
So a thirstier atmosphere is going to lead to more evaporation if there's water available. So you end up with more evaporation from rivers and reservoirs. You end up with more evaporation from the soil and from the vegetation.
As the hotter air parches the landscape, wildfires become increasingly likely and devastating.
Our understanding of greenhouse gases and what they do in the atmosphere goes back a long ways. It's kind of really kind of basic physics.
In 1856, a scientist named Eunice Foote predicted the warming effect of CO2. Her experiment featured glass canisters of various gases left to heat up in the sun. She observed the canister with CO2 heated quickest and stayed hot longest. Within the century, her predictions were proven correct. Scientists all over the world had collected decades of data, showing an upward trend in the temperature at the same time as an uptick in atmospheric CO2 levels. By the Cold War era, global warming became an aspect of national security. The US strategized to maintain economic and therefore militaristic supremacy over the Soviets. It was imperative to keep the USSR's frozen tundras from becoming a breadbasket. A naval officer named Roger Revelle testified before Congress in 1956 about the threat of the USSR's northern coast becoming free of ice, which would create navigable port cities for shipping. The Cold War naval studies of atmospheric CO2 are still used by climatologists today to track the rise of greenhouse gases. Recently, the conversation has shifted to the local economics of changing temperatures. Casco Bay off Portland, Maine, was the heart of the lobstering industry in the 1970s. Now, Casco Bay has warmed by 1.5 Celsius since 1993, driving the lobsters toward Canada.
Their water temperature has hit that sweet spot that we were in the 70s and the 80s, and we've climbed above that.
In Casco Bay, lobsters have gone far off the coast to find their colder, deeper waters. The fishing industry feels the effects of this migration.
It increases the costs. Bigger boats, more fuel, more crew, heavier rope. And everything about it increases the cost to maintain that same weight.
We're going to have to do an awful lot of adaptation because the planet is changing and it's going to continue to change.
Some argue that change is natural.
As everything else in nature, it adapts to it. There's ebbs and flows throughout all of the natural world, and we're just part of that.
Change that may have taken thousands, if not tens or hundreds of thousands of years, we as humans are making changes in hundreds of years. And so it's really hard for Earth and the biosphere in particular to adapt to those really rapid changes.
You can look in deep time, millions of years ago, you can look at events where the climate warmed on average 3, 4, 5, 6 degrees centigrade. And almost always really bad things happened, including mass extinctions.
For each degree of warming, you can kick off these more and more of these positive feedbacks that can lead to more and more warming. So for example, in the Arctic and the Antarctic, and the ice and snow reflects solar radiation back to space. So it kind of prevents the planet from absorbing as much energy as it would. And if you melt that ice, then you're gonna have more of the incoming radiation from the sun being absorbed by the planet.
An image many people have in their head is the Hiroshima bomb that we have in the atmosphere. We are adding an additional 1.6 million times that amount of energy. And so how is Earth going to handle that?
It's a change that's very real and it's getting bigger. And what that means is that we are breaking records all of the time, much more than we would expect from just natural variability that occurs.